All right, let's work a few more examples. Our next example is nitrogen trifluoride. All right, we know that fluoride is the most electronegative element, so nitrogen must be the least electronegative. It goes in the middle, and then we're going to connect the fluorines to get our skeletal structure. All right, let's count the total number of valence. If we look on the periodic table, we find that nitrogen should have 5 valence electrons, and each fluorine would have 7, and we have 3 fluorines. So we have 21 plus 5 valence electrons with no charge to consider. So we have 26 valence electrons. All right, we have already used 3 bonds, so that is 6 electrons. So now I'm going to start putting octets around each atom. Remember that one bond already donates 2 electrons to the octet. So I've used 6 electrons, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. They all have an octet, so now I move to the central atom and give lone pairs. 25, 26. All right, now on to, double check that each atom has an octet, and it does, and this is the acceptable structure for nitrogen trifluoride. Our next example is carbonic acid, and you can see that we have carbonate in there, and we know that carbon is going to be our central atom. It's the least electronegative. I'm going to attach the oxygens. And then we need to attach the 2 hydrogens. This is an acid, and this is where you need to recognize that the hydrogens go on the oxygens. It doesn't matter which oxygen as long as it's separate oxygens. So we have 4 valence from the carbon, 6 times 3 equals 18 from the oxygen, and then hydrogen has 1 valence times 2 of them. It is a common mistake that hydrogen has 2 valence. Our brain plays tricks on us, but just remember hydrogen only has 1 electron, and in this case I have 2 hydrogens. So I have 18 plus 2 is 20, plus another 4 is 24 valence electrons. And I have used 1, 2, 3, 4, 5 bonds times 2 electrons is 10 electrons. Now I need to give octets. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right. It is clear that the carbon does not have an octet, so I need to borrow a lone pair from this oxygen. It must be the oxygen with no other bonds attached to it, because oxygen does not readily form 3 bonds easily. And so it's better to use this oxygen and then add in the double bond. All right, for the next example, we have astatine pentabromide. The astatine is the least electronegative. We're going to put that in here and attach all of our bromines. We have astatine is in the group with 5 valence. Bromine has 7 valence times 5 electrons. It's 35 plus another 5. We have 40 valence electrons we need to account for. So this starts to be a lot of electrons. We have made 5 bonds, so we've already used 10 electrons, and we have 30 more to do. So if you actually consider the 40 electrons distributed over the 5 atoms, that's 8 each. So you know that each one is going to get its octet. So 2, 4, 6, and then 2 more from the bond. So this will finish out our structure. But notice we had to break the octet rule to even form the skeletal structure. You can break the octet rule only if you absolutely must break the octet rule to connect all of the atoms, or continue putting lone pairs on the central atom if you have more. So when we go to our geometry, I will show you more about this exception to the octet rule and why it exists.